Hi everyone, I'm Detum Samrasekara. Today I'm going to talk about DNS. DNS means Domain Name System. What is the Domain Name System? It's a kind of an internet phone book. Same way we have our mobile phone book. In that, since we can't remember the phone numbers, we save the phone numbers under the names. And whenever we want, we can record it by the name. Uh, Same concept applicable in here. Since we can't remember the IP addresses, uh, the name of the website will help us to uh, get the IP. Actually, the DNS uh, play a good role here. The DNS will find the IP address when we give the name of the website. When the user type the domain name google.com or facebook.com in the browser, DNS is finding the correct IP address for the site. Then the browser uses the address to communicate with origin server or CDN server to access the information of the website. Um, in the typical DNS query without any caching, there are 4 servers that work together to deliver an IP address to the client. Recursive resolvers, root name servers, TLD name servers, and the authoritative name servers. The DNS resolver receives the query from the DNS client and then interact with the other DNS servers to hunt down the correct IP. Once the resolver receives the request from the client, the resolver then actually behaves as a client itself, querying the other 3 type of DNS servers in search of the right IP. First, the resolver queries the root name server. The root server is the first step in translating human readable domain names into IP addresses. The root server then responds to the resolver with the address of the top level domain. Top level domain means the .com, .net. Um, and next, the resolver queries the TLD server. Then the TLD server responds with the IP address of the domain authoritative name server. The recursor then queries the authoritative name server, which will respond with the IP address of the origin server. The resolver will finally pass the origin server IP address back to the client. Using the IP address, the client can then initiate a query directly to the origin server, and then origin server will respond by sending website data that can be interpreted and displayed by the web browser. What is the DNS caching? Apart from the above mentioned process, recursive resolvers can also resolve DNS queries using cached data. After retrieving the correct IP address for a given website, the resolver will then store that information in the cache for the limited amount of time. During the time period, if any other client send a request for the domain name, the resolver can skip the typical DNS lookup process and simply respond to the client with the IP address saved in the cache. Once the caching time limit expires, then the resolver must retrieve the IP address again. What happens when a DNS server fails? Um, Actually, a DNS server can fail for multiple reasons, such as power outage, cyber attacks, and hardware malfunctions. In earlier days of the internet, DNS server outage could have a relatively large impact. But today, there is a lot of redundancy built into DNS. As an example, there are many instances of the root DNS servers and TLD name servers, and most of the IPs have backup recursive resolvers for their users. In the case of major DNS server outage, some users may experience delays due to the number of requests being handled by backup servers. But it would take DNS outage of very large proportions to make significant portion of the internet unavailable. This is one of the attack for the domain name system provider called DYN in 2016. Actually, it is the biggest DDoS attack in history, one of the biggest. Let's move on to Wireshark now. First, we will check some DNS. In here, you can see the DNS. This is the DNS. Actually, this should be my router, and there are some more commands for displaying DNS. These are the DNS. From this you can see the DNS in each and every. And now I am going to flush all the DNS. And I will clear the cache. Now I'm starting Wireshark. And I'm going to search facebook.com. And now I have enough packets here. So I'm stopping the Wireshark packet receipt. In here, first we have to filter from DNS. And here we can see the query for Facebook. And in that query, we can see the destination port as 53. And also you can see it's using the UDP. And this is the response. And that response, the source port is 53. And here there are one answer. This is the answer. Actually, it's a type A. Type A means host, and it's requesting the host IP. Other than that, we can see the source IP is this, and the destination. Sorry. Yeah, the source IP is this one, and the destination IP is it. This is the query. It's requesting the host address. Other than that, there are more tools, NS lookup, and here we can use NS lookup facebook.com. Let's give us the Facebook IP. You can see the same IPs here. Thank you very much.